Welcome to our deep dive into the state of large language models. To understand the significance of Deepseek V3.2, we must first visualize the current landscape. Let's plot model performance against time. Recently, we've witnessed a troubling divergence. While proprietary, closed-source models have accelerated exponentially, shown here in red, the open-source community, despite its efforts, has followed a shallower trajectory. This creates a widening performance gap. But what exactly is holding open models back? First, there is an architectural bottleneck, inefficient attention mechanisms that struggle with long contexts. Second, a resource disparity, limited post-training compute prevents these models from fully maturing. And finally, a capability ceiling, weak agent generalization, making them less effective at complex, real-world tool use. This divergence seemed inevitable, until now. Enter Deepseek V3.2. Let's explore how this model bridges the gap and redefines the frontier. To understand the leap forward in version 3.2, we first need to look under the hood at how the model processes information. Let's compare the standard approach with Deepseek's innovation. On the left, we have vanilla attention. This is how most traditional models think. Imagine reading a book where, for every new word you read, you are forced to stop and reanalyze its relationship with every single previous word on every page. This creates a dense, computationally heavy map. As the text gets longer, the work required explodes. It is thorough, but incredibly expensive. Now, look at the right. This is Deepseek Sparse Attention, or DSA. Instead of looking at everything, the model learns to be selective. It maintains focus on the immediate context, the diagonal, and efficiently hops to only the most relevant distant information blocks. By ignoring the noise, DSA drastically lowers the computational complexity from a dense square to a sparse scatter. This is the key to long context efficiency. It allows V3.2 to process massive amounts of data without the model slowing to a crawl, solving one of the biggest bottlenecks in open-source AI. Having addressed efficiency with DSA, we move to the second pillar of this breakthrough. The scalable reinforcement learning framework. Traditionally, the vast majority of a model's intelligence is purchased during the massive pre-training phase, with post-training often treated as a final, lightweight polish. Deepseek V3.2 flips this paradigm. It introduces a robust protocol that allows for massive scaling of compute after the base training is done. We are talking about a post-training budget that now exceeds 10% of the initial pre-training cost. This isn't just fine-tuning. It is deep, intensive reinforcement learning. This heavy investment in thinking time yields specific, high-level reasoning capabilities. The model achieves gold medal performance in the International Mathematical Olympiad, and similar mastery in the International Olympiad in Informatics. This high compute variant is known as Deepseek V3.2 Special. By shifting resources from passive learning to active reasoning, it doesn't just catch up, it surpasses the performance of GPT-5. Building on the efficiency of sparse attention and the power of reinforcement learning, we encounter a third challenge: the generalization lag in agentic tasks. Open models often struggle to effectively use tools or follow complex instructions in new environments. To bridge this gap, Deepseek V3.2 introduces a three-stage pipeline. It begins here, with a cold start, by unifying reasoning data with tool use trajectories. The model learns the fundamental mechanics of how to think and act simultaneously. But a seed isn't enough. We need a forest. This leads to the second, and most critical stage, large-scale task synthesis. Instead of relying solely on human annotated data, the system generates its own training ground. It synthesizes over 1,800 distinct environments and 85,000 complex prompts. Imagine the model practicing in thousands of virtual simulations, from coding terminals to web browsers, refining its skills at a massive scale. This massive synthetic training data feeds into the reinforcement learning process, resulting in the final output, a robust agent. This agent doesn't just answer questions. It generalizes. It can navigate interfaces and execute tasks with a level of proficiency that rivals proprietary systems, effectively closing the open source gap in agentic capabilities. So, where does all this architectural innovation and massive scale reinforcement learning leave us? Let's look at the numbers. Here is the landscape of modern AI performance. For months, the open source baseline has been impressive, but it has hit a plateau, struggling to close the widening gap with proprietary giants like GPT-5. The difference in complex reasoning has been stark. But Deepseek V3.2 changed the equation. By combining the efficiency of sparse attention with the reasoning depth of the special post-training pipeline, the model doesn't just catch up. It pushes the frontier forward. This isn't just general chatter. We are seeing state-of-the-art results in reasoning, achieving gold medal performance in math Olympiads, dominance in coding tasks, and a massive leap in agentic capabilities, allowing the model to navigate complex tools and environments that were previously out of reach for open models. Deepseek V3.2 proves that with the right architecture and training dynamics, open models aren't just following the leaders, they are becoming them.